one small step for man, one giant leap for mankind.
The Apollo 11 mission stands as one of humanity's most significant achievements, representing a pinnacle of technological innovation, determination, and exploration. It was the culmination of years of planning, development, and testing aimed at landing humans on the moon and bringing them safely back to Earth. The mission occurred during the intense backdrop of the Cold War rivalry between the United States and the Soviet Union. The United States Apollo program aimed to demonstrate technological superiority and achieve a monumental feat that would secure its place as a leader in space exploration. The primary objective of the Apollo 11 mission was to successfully land humans on the moon's surface, allowing them to explore, conduct experiments, and return safely to Earth. This mission was the realization of President John F. Kennedy's 1961 challenge to put a man on the moon before the end of the decade. The crew of Apollo 11 consisted of 3 astronauts: Neil Armstrong, the mission commander, responsible for piloting the lunar module and becoming the first person to set foot on the moon; Edwin "Buzz" Aldrin, the lunar module pilot, who joined Armstrong on the moon's surface for scientific activities; Michael Collins, the command module pilot, who remained in lunar orbit aboard the command module, while Armstrong and Aldrin explored the moon's surface. Apollo 11 launched on July 16, 1969, from Kennedy Space Center in Florida, propelled by the Saturn V rocket, the most powerful rocket ever built. After achieving Earth orbit, the Saturn V's third stage fired again to propel the spacecraft out of Earth's gravitational influence and onto a trajectory toward the moon. The command and service modules separated from the lunar module, which would later land on the moon. The command modules, piloted by Collins, entered lunar orbit while the lunar module prepared for descent. On July 20, 1969, Armstrong and Aldrin descended in the LM, named Eagle, to the moon's surface in the Sea of Tranquility. Armstrong's historic words marked the moment as he stepped onto the moon's surface.
That's one small step for man, one giant leap for mankind.
Followed by Aldrin. They conducted experiments, collected samples, and planted the American flag. After a successful moonwalk, the lunar module ascent stage rejoined the command and service modules piloted by Collins in lunar orbit. The lunar module ascent stage docked with the command and service modules, and the crew transferred back to the command and service modules. The command and service modules, with the crew aboard, began its journey back to Earth. On July 24, 1969, the spacecraft splashed down in the Pacific Ocean, safely concluding the historic mission. The Apollo 11 mission left an indelible mark on human history, inspiring generations and serving as a testament to human ingenuity and perseverance. The images, videos, and scientific data collected during the mission provided valuable insights into the moon's geology, leading to a better understanding of the solar system's formation. The Apollo 11 mission remains a defining moment in the exploration of space, showcasing humanity's ability to achieve the seemingly impossible. The mission's success served as a stepping stone for future space exploration endeavors and solidified the United States' position as a leader in the realm of space travel. The story of Michael Collins, the often less acknowledged astronaut of the Apollo 11 mission, has gained new attention due to his emergence from relative obscurity and his decision to share undisclosed aspects of the mission. This newfound revelation has ignited curiosity about the experiences, discoveries, and secrets that Collins encountered during his journey to the moon. Michael Collins' role in the Apollo 11 mission was crucial, but often overshadowed by the attention given to Neil Armstrong and Buzz Aldrin, who set foot on the moon's surface. Collins piloted the command module, a pivotal component responsible for lunar orbit and the safe return of the crew to Earth. Collins' decision to share untold aspects of the mission might be driven by several factors. The passage of time, coupled with a desire to preserve and share the historic significance of the Apollo 11 mission, could be motivating him to open up about his experiences. The details of the undisclosed experiences Collins encountered during the mission remain a mystery, sparking speculation among enthusiasts and experts alike. These could range from personal reflections on his role in the mission to the psychological and emotional impact of isolation in space. The revelation of these hidden aspects raises intriguing questions. What exactly did Collins encounter during his time alone in lunar orbit? Were there unanticipated challenges, moments of awe, or even unexplained phenomena that he witnessed? Did he gain unique insights into the universe, Earth, or the human condition? Collins' decision to share his experiences adds a layer of complexity to the Apollo 11 mission's narrative. His perspective as an essential yet often overlooked participant provides a different lens through which to view the historic achievement. Collins' revelation underscores the shared human experience of exploration, curiosity, and the quest for knowledge. It serves as a reminder that even those who play behind-the-scenes roles in monumental events can have profound insights to offer. In summary, Michael Collins' emergence from the shadows and his decision to share undisclosed aspects of the Apollo 11 mission adds depth to the historic achievement. It invites us to ponder the untold stories of individuals who contributed to significant moments in history and encourages us to appreciate the complexity and richness of human exploration and discovery. The Apollo 11 mission holds immense significance in human history for a variety of reasons. The mission achieved the monumental goal set by President John F. Kennedy of landing a man on the moon and returning him safely to the Earth. Neil Armstrong's iconic words, "That's one small step for a man, one giant leap for mankind," marked the first time humans had set foot on another celestial body. Apollo 11 represented a triumph of human curiosity and exploration. It showcased humanity's ability to overcome challenges and push the boundaries of what was thought to be achievable. The mission inspired future generations to dream big and pursue careers in science, technology, engineering, and mathematics. The mission brought back valuable scientific data and lunar samples that significantly advanced our understanding of the moon's geology, composition, and history. The rocks collected during the mission provided insights into the moon's formation and its relationship to Earth. The Apollo 11 mission pushed the limits of technology at the time. The development of the Saturn V rocket, the lunar module, and the command module showcased the United States' prowess in engineering and aerospace technology. Many innovations developed for the mission had broader applications in various industries. The successful moon landing demonstrated human achievement on a global scale, transcending national boundaries. The images and footage from the mission were broadcast to millions of people around the world, fostering a sense of shared wonder and inspiration. The United States' successful moon landing marked a pivotal moment in the Cold War-era space race between the U.S. and the Soviet Union. It showcased American technological and scientific superiority and served as a symbol of democratic achievement during a tense geopolitical period. The Apollo 11 mission paved the way for subsequent lunar missions, including Apollo 12, 14, 15, 16, and 17. These missions continued to advance our knowledge of the moon and provided opportunities for further scientific research and experimentation. While driven by national competition, the Apollo 11 mission also highlighted the potential for international collaboration in space exploration. It spurred interest in cooperative ventures, such as the International Space Station decades later. The success of Apollo 11 inspired advancements in various fields, from materials science to computing. It showed that seemingly insurmountable challenges could be overcome through creativity, dedication, and collaborative effort. The mission left an indelible mark on popular culture, influencing literature, art, film, and music. It captured the imagination of people worldwide and continues to be a source of inspiration for creative expression. The Apollo 11 mission encompassed two pivotal phases: the launch from Earth and the historic lunar exploration. Both of these phases were essential in achieving the mission's primary objective of landing humans on the moon and returning them safely to Earth. The Apollo 11 mission began with a remarkable launch on July 16, 1969, from Kennedy Space Center in Florida. The launch vehicle was the Saturn V rocket, the most powerful rocket ever built at that time. The Saturn V was a multi-stage rocket that consisted of 3 stages, each equipped with powerful engines to propel the spacecraft out of Earth's atmosphere and into space. The launch sequence involved the ignition of the first stage, which burned its fuel and detached after several minutes. The second stage then ignited and eventually separated, followed by the third stage, which carried the Apollo spacecraft into Earth's orbit. The command and service module containing astronauts Neil Armstrong, Buzz Aldrin, and Michael Collins was safely positioned in orbit around the Earth. After orbiting Earth, the command and service module fired its engines for the trans-lunar injection, a critical maneuver that propelled the spacecraft out of Earth's gravitational pull and onto a trajectory toward the moon. This marked the beginning of the journey to the lunar destination. The command and service module entered lunar orbit after a journey of about 3 days. The lunar orbit insertion maneuver required precise calculations and engine burns to slow the spacecraft down enough to be captured by the moon's gravitational field. The lunar module, named Eagle, detached from the command and service module and began its descent to the moon's surface. On July 20th, 1969, Neil Armstrong and Buzz Aldrin entered the LM and piloted it to a successful landing in the Sea of Tranquility. Armstrong's famous words marked the historic moment, as he became the first human to set foot on the moon, followed shortly by Aldrin. Armstrong and Aldrin conducted experiments, collected samples, and planted the American flag on the moon's surface. They also tested the mobility of their spacesuits and the lunar rover. The scientific instruments and samples gathered provided valuable insights into the moon's geology and history. After spending approximately 21 hours on the moon's surface, Armstrong and Aldrin returned to the lunar module ascent stage and launched off the moon. The lunar module rendezvoused and docked with the command and service modules piloted by Michael Collins in lunar orbit. The three astronauts were reunited, and the lunar module descent stage remained on the moon's surface. The command and service modules began its journey back to Earth, leaving lunar orbit and setting a course for re-entry. The command and service modules re-entered Earth's atmosphere, and its heat shield protected it from the intense heat generated during re-entry. The parachutes deployed, and the command and service modules safely splashed down in the Pacific Ocean on July 24, 1969. Michael Collins' role in the Apollo 11 mission. Michael Collins played a crucial and often underappreciated role in the success of the Apollo 11 mission. As the command module pilot, Collins was responsible for several critical aspects of the mission that contributed to the safe landing on the moon and the astronauts' return to Earth. While Neil Armstrong and Buzz Aldrin descended to the moon's surface in the lunar module, Collins remained in orbit around the moon in the command module named Columbia. This position allowed him to maintain communication with both the lunar module on the moon's surface and mission control back on Earth. He relayed vital information, provided updates on the lunar module status, and ensured that the astronauts on the moon could stay in contact with Earth. One of the most complex and challenging aspects of the mission was the rendezvous and docking of the lunar module with the command module after the moonwalk. Collins had to use precise calculations and execute maneuvers to guide the command module and lunar module to reunite in lunar orbit. The successful execution of this maneuver was essential for the astronauts' safe return to Earth. After the lunar module had returned to the command module following the moonwalk, Collins piloted the command module containing all three astronauts back to Earth. The re-entry phase was a critical moment, as the command module re-entered Earth's atmosphere at high speeds. Collins' expertise ensured that the command module heat shield effectively protected the astronauts from the intense heat generated during re-entry. During his time in lunar orbit, Collins had the opportunity to observe the moon from a unique vantage point. He used this time to take photographs and make observations of the lunar surface, contributing valuable scientific data. His observations added to the overall understanding of the moon's features, terrain, and geological formations. Collins also demonstrated remarkable psychological resilience during his periods of isolation when the command module was on the far side of the moon, out of contact with both the lunar module and Earth. Despite the loneliness and isolation, he maintained his focus on the mission's objectives and ensured that he carried out his responsibilities diligently. Collins' role as the command module pilot was essential for the mission's success. His ability to navigate, communicate, and execute complex maneuvers played a pivotal role in the astronauts' safe return. While he didn't get the chance to walk on the moon's surface like Armstrong and Aldrin, his contributions were integral to the historic achievement of Apollo 11. Michael Collins' Solitude and Reflections. During the Apollo 11 mission, one of the unique aspects of Michael Collins' role in the Apollo 11 mission was his experience of solitude during his orbits around the moon, particularly when the command module was on the moon's far side, out of contact with both the lunar module and Earth. This isolation provided Collins with moments of introspection and deep reflection on his place in the universe, the mission, and humanity's journey into space. During each orbit around the moon, as the command module passed behind the moon's far side, Collins experienced temporary radio silence. This meant he was effectively cut off from communication with both the lunar module on the moon's surface and mission control back on Earth. This isolation gave him an opportunity to contemplate his surroundings, the mission's objectives, and his personal perspective on the universe. In these moments of solitude, Collins had the unique privilege of looking out into the vast expanse of space from a perspective very few humans had ever experienced. He pondered profound questions about the nature of existence, humanity's place in the cosmos, and the significance of the mission he was a part of. Collins' experience of viewing Earth from the moon's orbit is often referred to as the overview effect. This term describes the profound shift in awareness and perspective that astronauts experience when seeing Earth from space. The sight of our planet as a fragile and interconnected sphere in the vastness of space often leads to feelings of unity, interconnectedness, and environmental consciousness. Collins' reflections during his periods of solitude allowed him to recognize the interconnectedness of all life on Earth. He saw the planet as a small, fragile entity suspended in the cosmos. This realization sparked a deeper sense of responsibility for the planet and its preservation. After his return from the Apollo 11 mission, Collins became an advocate for environmental conservation. His experience of seeing Earth from space inspired him to promote a greater understanding of the need to protect and preserve our planet. He recognized the importance of taking care of our spaceship Earth. Collins' introspective moments in space had a lasting impact on his worldview and his advocacy efforts. He encouraged people to view the Earth from his perspective, a perspective of unity and shared responsibility. His reflections and advocacy helped raise awareness about environmental issues and the importance of sustainable practices. Spiritual transformation and environmental advocacy. Michael Collins post-Apollo 11 journey. Michael Collins' experience as the command module pilot during the Apollo 11 mission had a profound impact on his spiritual outlook and his subsequent advocacy for environmental conservation. His time in space, especially the moments of solitude and reflection, led to a transformation in his perspective on life, the universe, and humanity's role in protecting the planet. Viewing Earth from space gave Collins a unique vantage point that fostered a deep sense of interconnectedness. He saw Earth as a fragile, isolated orb in the vastness of space, and this perspective prompted a profound spiritual shift. He began to view Earth as a precious entity that must be cared for and preserved. Before his space journey, Collins was not particularly religious, but his experiences in space led him to embrace a more spiritual perspective. He saw the universe as an organized and purposeful creation, rather than a chaotic one. This transformation influenced his belief in a higher order and his sense of wonder about the cosmos. Collins' new perspective inspired him to advocate for environmental conservation. He recognized the fragility of Earth and the need for humans to take responsibility for its protection. He often spoke out about the importance of preserving the planet for future generations. Collins popularized the term spaceship Earth to emphasize the limited resources and interconnectedness of our planet. He likened Earth to a spaceship with finite supplies, urging humanity to adopt sustainable practices to ensure the well-being of all its passengers. After his time with NASA, Collins supported initiatives that aimed to address environmental challenges. He worked with organizations dedicated to conservation and encouraged leaders to prioritize environmental issues on a global scale. Collins' unique perspective as an astronaut lent credibility to his environmental advocacy. His words resonated with people around the world, raising awareness about the need to protect the planet. His advocacy contributed to the broader environmental movement of the 20th century. Michael Collins' spiritual transformation and subsequent environmental advocacy left a lasting legacy. His experiences during the Apollo 11 mission allowed him to see Earth from a perspective that few have ever witnessed. This perspective transformed him into a passionate advocate for environmental stewardship, inspiring others to see the world in a new light and take action to protect it. Collins' journey exemplifies how space exploration can lead to personal growth and a greater sense of responsibility for our planet. His legacy serves as a reminder that the awe-inspiring views of our world from space can spark meaningful change and inspire individuals to become proactive caretakers of spaceship Earth. Legacy of Apollo 11 and space exploration, shaping humanity's future. The legacy of the Apollo 11 mission and space exploration extends far beyond the historic moon landing itself. It has had a profound impact on science, technology, culture, and the way humanity envisions its future. Here are some key aspects of the legacy. Apollo 11 provided valuable scientific insights about the moon's geology, composition, and history. The samples collected by Armstrong and Aldrin continue to be studied by scientists, expanding our understanding of lunar evolution. The technology developed for the Apollo missions laid the foundation for modern space exploration. Advances in rocketry, spacecraft design, and navigation systems have propelled subsequent missions to explore other planets, asteroids, and beyond. The need for precise calculations and navigation led to the development of advanced computing systems. The miniaturization of computers for space use paved the way for innovations in personal computing and the digital age. The challenges of space travel drove innovations in materials science and engineering. New materials were developed for spacecraft and suits, influencing industries from aviation to consumer products. The Apollo 11 mission captured the world's imagination and inspired generations to dream big and pursue careers in science, technology, engineering, and mathematics (STEM). It demonstrated what humans can achieve when united by a common goal. The blue marble image of Earth taken from space highlighted the fragility and interconnectedness of our planet. This perspective fostered a sense of global unity and awareness of environmental issues. Apollo 11 paved the way for subsequent human space missions, including the Space Shuttle program, the International Space Station, ISS, and future plans for lunar and Martian exploration. The success of Apollo 11 fueled interest in robotic missions to explore other planets, moons, and celestial bodies. Robotic missions have revealed insights about the solar system's history and potential for habitability. The international response to Apollo 11 highlighted the power of collaboration and diplomacy in space exploration. It set a precedent for international partnerships in future missions and space endeavors. Vision for the future. The legacy of Apollo 11 continues to shape space agencies' ambitions, with plans for returning to the moon and eventually sending humans to Mars. These endeavors build on the knowledge and experience gained from past missions. The success of Apollo 11 contributed to the growth of the commercial space industry. Private companies are now developing technologies to expand humanity's reach in space. In summary, the legacy of Apollo 11 transcends its historical significance as a singular achievement. It represents the potential of human innovation, determination, and collaboration. The mission's impact on science, technology, culture, and future exploration serves as a beacon of inspiration for current and future generations, encouraging us to explore the cosmos and push the boundaries of human achievement.